Hey guys, welcome to a new episode of Twitter Talks, the one and only Moroccan podcast made to know more about Mars planet and what makes Mars an inspiration for everyone. Whether you're a student, teacher, astronaut, or someone interested in astronomy, then you are in the right place to get to know Mars. Are we really going to Mars? Maybe in 2024 or 2030? It's real, and this is what we will know about today. I'm really happy to have one of the leaders of human exploration of Mars, American aerospace engineer, author of more than 10 books, Mr. Robert Zubrin, the president of the Mars Society and president of Pioneer Astronautics. Hi, Robert. I'm very happy to have you here with us today, and thank you for your valuable time.
Well, thank you for inviting me. I'm very happy to be able to speak to people in Morocco about Mars.
Thank you so much, Mr. Robert. Great to have you. Robert, if you could just give us a brief introduction about yourself and your work as a president of the Mars Society.
Okay. Well, I'm an aerospace engineer. I have been working on space since the 80s. I believe that Mars is the new world that will be the key to humanity becoming a multi-planet species. It's the closest world that has on it all the materials needed to support life and therefore also technological civilization. And that if we can go to Mars, we can not only make great discoveries about the nature of life, we can open a new planet for humanity and a new epic in human history. So I have contributed to Mars technology and to plans for Mars missions on the technical front, but also after I published my book, The Case for Mars in 1996, and I got an enormous response from people of all over the world, basically asking, how can we make this happen? I and some friends decided to start the Mars Society, which was started in 1998. And we have about 7,000 members in 40 countries, and other members who are not in chapters as well. And we do three things. One is just public education to spread the vision. Second is political work to try to convince the political powers in the different countries to support Mars exploration. And the third is projects of our own, of which the most important have been the establishment of our practice Mars stations, our Mars analog research stations in the desert and in the Arctic, and also our contests, for instance, the rover contests, where we encourage university engineering students to build Mars rovers, and we compete them in the desert to see which can do the best exploration.
Okay. It's very interesting. By the way, Mr. Robert, I loved your book, Mars Direct Humans to the Red Planet Within a Decade. A very important and wonderful book. It looks at the current situation of NASA and outlines a Mars Direct mission proposal with the SpaceX Dragon and considers the implications of interplanetary exploration for humanity. So it's very interesting. I will share the book link with our Moroccan community.
Right. So I think my best book is The Case for Mars. We just published a 25th anniversary edition of it just this last month, and it's the most complete explanation.
Yeah, it's very interesting. Thank you so much, Mr. Robert. So my first question is, why Mars? Why are the last few missions focusing on Mars? Why this big money, billions of dollars to explore Mars?
Well, as I said, it's the closest planet that has the materials on it that could support life, and also, therefore, a human future as well. But the space agencies, the officials, are mostly motivated by the first, that is, the science. And
Okay.
here's the basic story. Mars today is cold and dry. There's water, but it's all ice. But once upon a time, in the early Mars, it was warm and wet. There were rivers on Mars, there were lakes, there were oceans. And in fact, the early Mars was not that different from the early Earth. And here's what we know about the early Earth, that life appeared on Earth virtually as soon as it could, as soon as the Earth became cool enough for liquid water. 3.7 million years ago, we start seeing evidence of microbes on Earth. In other words, there was never a time when Earth
Okay.
was both habitable for microbes and sterile, that is, without any life at all. So the question is, since Mars and Earth were practically the same at that time, did life also appear on Mars?
Okay.
And even if it later on went extinct on the surface when the conditions became bad for life, um, if it ever was there, we could find fossils on the surface. And I actually believe that if it ever was there, it probably still is there because there is still liquid water, not on the surface of Mars, but underground where it's warmer. And
Okay.
you know, there are ancient life forms on Earth in the groundwater that were originally the dominant life forms on the surface of the Earth, but the surface became uninhabitable for them once plants put oxygen in our atmosphere. They went
Okay.
underground 3 billion years ago. They're still there. They're still there hiding out after all this time. The original first life on Earth can still be found underground on Earth. So if there was ever life on the Martian surface, I think that as the surface became uninhabitable, they would have retreated into the groundwater and we could find them by drilling. And see, there's two things here. One is, okay, was there life? And the question is, was it the same as Earth life or different? See, because all Earth life at the biochemical level is the same. That is, it all uses the same information system, okay? DNA and RNA, the same alphabet. Now, you know, all Western Europeans use the same alphabet. They use the Latin alphabet, the alphabet of the Romans.
Yeah.
We English speaking people use it, the French use it, the Spanish use it, the Italians use it, the Germans use it. Okay. And of course, it is used to some extent in Morocco, but of course, you also use the Arabic alphabet. Now, if someone was born in Europe or North America and never traveled, they would think that the Latin alphabet was the only kind of alphabet there could be. Okay, now if they traveled to Morocco, they'd see, well, here's a different alphabet. Okay, although the Arabic alphabet and the Latin alphabet both have a common root in the Phoenician alphabet from
Yeah.
long ago. And even though the letters look very different, and of course the words are different, it uses the same set of principles of representing words through sounds.
Yeah.
On the other hand, if you traveled as far as China, the Chinese have an alphabet which does not have a common origin with the Arabic or Latin alphabet. And it doesn't even work on the same set of principles. It's not based on sounds at all. It's based on pictures, actually.
Yeah.
And so that's a completely separate origin. So the question is this: all life on Earth uses DNA and RNA, the Latin alphabet, if you will. Does life on Mars use that alphabet? In other words, is that the alphabet of life, period, full stop? Or
Mhm.
could it be significantly different, like the Arabic alphabet, or entirely different, like the Chinese alphabet?
Yeah.
So, in other words, is life as we know it on Earth what life is? Or is it just one example of a much bigger set of possibilities?
Yeah. But Mr. Robert, many people are objecting, saying that first we have to deal with our problems here on Earth, such as poverty, education, healthcare, and so many other issues. So, what is your take on that?
Well, I think that if more people were thinking about how we can open up new worlds instead of fighting over this one, we'd all be a lot better off.
Yeah, exactly. Yeah, exactly. Mr. Robert, I have a question about commercial goals. So, should humankind's boldest exploration be driven by commercial goals?
Well, commercial is one thing that can and will drive human expansion into space. It should
Mm,
not be the only thing. We can also go for knowledge. We can also go for, how can I put it, hope. You know, many of the people that came to America in the early colonies didn't come here to make money. They came here to start a new life. Many of them were members of religious groups that were persecuted in their own countries, and they came to have a place where they could have their own world, so to speak, make their own rules, um, which I
yeah.
think is very important to people. Um, I think people will come for all sorts of reasons.
Okay. I see. I see. It's an important answer. So, Mr. Roberts, are there currently any technological challenges left that don't enable us to send an astronaut to Mars?
Well, yes and no. Okay, let me put it to you this way.
Okay.
From a fundamental technological point of view, the answer is no. Okay, that is, we understand all the scientific principles needed to send humans to Mars and back. Okay,
Okay.
we know how to do it. Now, there's hardware to be developed, there's engineering to be done. Okay, right now, our heaviest Mars lander can only land 1 ton on Mars. We need Mars landers that can land at least 10 tons on Mars if we want to be able to send people to Mars. But this is not a fundamental issue. This is not like, you know, Los Alamos 1943, where they're going into new realms of physics. Can we make an atomic bomb? No, this is just engineering.
Okay. Good. But what exactly do we have to make, Mr. Robert?
Well, okay, we need to have functional heavy lift booster.
Okay.
Now we kind of have one right now with the Falcon Heavy. It's with 60 tons to orbit, a bit at the low end of what I would like. But the SpaceX company is working on Starship, which will have 120 tons to low Earth orbit, and that will be fine. NASA is working on the SLS, which would be over 100 tons to Earth orbit. That would be fine. We know how to do this. I believe, you know, that we will see both SLS and Starship reaching orbit within 2 years. You know, Musk says it'll be sooner, but 2 years. And that, so we need the heavy lift booster. That is being worked on right now. In fact, they were going to test fly the Starship today, but the weather or something, they have to postpone till tomorrow. But this is happening as we're talking. Then we need a heavy lander. I just wrote an article that was published in Scientific American on why we should develop a heavy lander, and we could start using it, sending platoons of robots to Mars instead of one at a time. We'll send 20 of them at a time, and have much more powerful robotic exploration missions. And in addition, the robots could help build up a Mars base before people ever go to Mars. So it's all ready when you get there. I think there's a strong case to be made for this. And I think sooner or later, NASA will come around to that point of view. We need to develop additional equipment. It's extremely important to be able to generate power on the surface of Mars. That can be done with either solar panels or nuclear reactors. We need to be able to make rocket propellant on the surface of Mars. The raw material is there in the form of carbon dioxide and water ice. If you do the chemistry, you can turn that into methane and oxygen, which is a very good rocket propellant, and in fact is the propellant that Starship uses.
Okay.
So, and we need Mars spacesuits, and things like this, and Mars vehicles. But there's a whole bunch of things that needs to be developed, but none of this is in the realm of fantasy or science fiction. It's all in the realm of engineering.
Yeah. Yeah. So, our viewers, if you have any question, you can write this in comments. So, Mr. Robert, you talked about the war on Mars. So, my question is, what are the possibilities of producing the water on Mars?
Say that again, sir. I didn't quite catch the question.
Okay. So I say, what are the possibilities of producing the water on Mars?
Processing the water on Mars?
Yeah.
Okay. Well, you can do it. In fact, in Antarctica, where all the water there is frozen, they have a system, they call it a rod well, where what you do is you pump hot water down into the ice, and it uses its heat to melt some of the ice, and what comes up is cold water, but it's more water than you started in the first place. Okay. Because the hot water managed to melt some ice to come back up with it as cold water. So if you put down, say, 10 gallons of hot water, you get up 12 gallons of cold water. And you can, so long as you have a way to keep heating the water and pumping it, you can get more and more water out of the ice. And that is how we'll probably get water from Martian glaciers. We have found glaciers on Mars, pure water ice that is as far south as 38 degrees north, which is the same latitude as Athens on Earth. Okay, so really not that much farther north than Morocco. The glaciers are there. You don't have to go to the North Pole to get ice on Mars.
Yeah. So everything is achievable in that time period. If you say that we should be on Mars by 2030, so does it mean that the mission should leave a year before that?
Well, it takes 6 months to fly from Earth to Mars.
Okay.
So, and you can't leave just any time. I'd have to look at what the exact launch window is in 2030. There's a 2-month period called the launch window, and it happens every 2 years, or every 26 months. It's like that's when the bus comes, and you have to launch at that time. So that's why, for instance, the Chinese probe, the American probe, and the United Arab Emirate probe all launched to Mars within about a month of each other, and all reached Mars during February, of this year. Not the same day, but the same month. Yeah.
Thank you so much. Thank you so much, Mr. Robert, for this valuable informations about the Mars exploration. So, can we go over the questions from the public?
All right. Well, come up. Tell me a question you'd like me to answer first.
Okay. Walid say, my question is how to transform Mars to be like the Earth.
Okay, how to transform Mars to be like the Earth. It's a great question. That's called terraforming. And, the Earth itself has been transformed by life.
Okay.
It is the nature of life to take barren environments and make them fertile, friendly for life. That's why life on Earth has been a success, because it took over the Earth and changed the Earth. The early Earth, for instance, didn't have any oxygen in its atmosphere. That is a creation of green plants. The soil is a creation of plants and animals. Okay. And, there are places like here in Colorado, where I live, is mountains. And the trees, except for the very tallest mountains, they go right up practically to the top of the mountains. And then you ask yourself, how did those trees get to the top of the mountain? Okay, and the answer is that animals transported the seeds up the mountain. And by so doing, by making the forest go up to the top of the mountain, they created a bigger habitat for themselves.
Okay.
Well, we're going to take the seeds of life to Mars. Now, how do we make it so that they will grow there? Okay, because that's harder.
Yeah.
Well, first of all, we need to warm Mars. Got to make Mars warmer. Now, we know how to do that because, in fact, we're doing it on Earth. A lot of people are not happy about that. We're not doing it on purpose. We're doing it by accident. But we have this greenhouse effect where if you put certain gases in an atmosphere of a planet, you'll make it warmer. Now, on Earth, we're doing it by accident, by increasing the amount of carbon dioxide in the atmosphere. And I think a lot of people know about this. Well, if we actually wanted to warm a planet, okay, if we weren't doing it as an accidental byproduct of industrial activity, but we were doing it on purpose, we could do a much more effective job
Yeah.
than what we're doing now on Earth. Okay, we know how to make this happen. There are special gases that are 1,000 times more effective as greenhouse gases than carbon dioxide. And these are called fluorocarbon gases. And if we made them with big factories on Mars and put them into the atmosphere, we could warm Mars by 10 degrees centigrade within 50 years. And to compare, on Earth, the greenhouse gas effect that we have here has only warmed the Earth 1 degree centigrade since 1870. It's 1 degree in 150 years. We could warm Mars 10 degrees in 50 years if we were doing it on purpose.
Yeah.
And that itself would cause further warming because if you warm Mars, there's a lot of carbon dioxide that has been soaked into the soil. And if you warm it, it will outgas and thicken the carbon dioxide atmosphere of Mars a lot. And that will warm the planet even more. So at the end of the day, we'll probably warm Mars by 50 centigrade. And if you do that, those glaciers, those frozen ice mountains will start to melt. And the rivers of Mars will flow again. The lakes will fill up with water, and there will be rain.
Yeah.
Rain. And at that
important.
point, you could start spreading seeds around Mars.
Yes.
And
It's
we
very,
will make Mars green. We'll make the red planet green.
yes. Yes. So there is a question from my assistant Hamza. Hello, Hamza.
Hey, Robert, do you hear me? Osama, can you hear me?
I can
Yes.
hear you.
Yeah, so we talked earlier in the backstage, and we are very honored to have you in this talk. And I think a lot of Moroccan youth and students will follow this live and get inspired by all what you said about exploring Mars and all the challenges we are facing while exploring. So my question is, sorry, Osama,
I'm not getting. There's feedback.
yeah, there's a feedback from Osama, I think. So my question was like, you told us about a lot of challenges, and they are engineering challenges, and how can we train our future engineers to like think about solution to these problems and also train themselves? Like, I don't see in our universities in Morocco, I never heard about university or graduate student engineers working on some replicating some challenge in Mars and trying to solve it on Earth. You understand my question?
Well, sure. Okay. Well, there are. Well, first of all, there is simply we need more engineers for all reasons on Earth, and you know, young people love adventure, and the idea of using engineering to open up a new planet makes engineering part of a great adventure. And simply posing that as the future of what something that engineers can take part in and in fact lead, I think will encourage many more young people to become engineers and scientists. and that is something very healthy for society in general. The United States doubled the number of science and engineering graduates it had during the 1960s because of the Apollo moon program. And in fact, I myself am one of those young people, or was one of those young people, to become an engineer because I was excited about space because we were going to the moon. Now, most of those, my friends who also went into science and engineering for that reason, didn't end up doing space. Most of them ended up doing computers, and they became very rich. They built Silicon Valley. But that's okay. That's great, right? I mean, it's intellectual capital is the true wealth of a country. Really, it is. There are countries here, you could give everyone there $1 million, and 2 years later, they'd all be absolutely as poor as they are today. And there are other countries, like Germany and Japan were bombed flat at the end of World War II. And by 1960s, they were once again among the richest countries in the world. And it's because of intellectual capital. And so I think it would be a very good thing for Morocco, for the authorities in Morocco to encourage young people to think about the possibilities of engineering a multi-planet species. The Mars Society hosts these Mars rover competitions that I mentioned. We have them in the desert in Utah, and we also have had them in Poland. And we've had teams from Egypt come. I believe they had some sponsorship from the Egyptian government for some of the university teams in Egypt to build rovers and compete in these competitions. And I think it is because they understand the value of getting more young people to want to become engineers and also to develop their skills as engineers in this kind of way. And I think it would be a good thing if the Mars Society Morocco tried to interest some of the universities in creating a rover to compete in our rover competitions. We had to suspend them last year because of the COVID epidemic, but this will end and we will do this again. And I think those Egyptian students had a great experience in this. And in fact, I think they one of the competitions in Poland, they came in among the top 3 teams, which is very hard because there were over 30 teams in the competition. So this is a thing. And what does it say? For a nation to say, we want to be part of this. It's saying we want to be part of the future. We're as good as any other country. Our people are as good as any other people. We're not just, some third world people that need to be led by others. We can be among the leaders of the world.
Yeah, I think we should have more and more about like such international competitions. And honestly, as a group of Moroccan engineers, we are trying to promote this science and these experiments, like to have more, to motivate our students to do such things, like create rovers and robots and robotics, and be interested in these fields.
Now, there's also other things. There are particular instruments that are needed for Mars exploration that I think are relevant to a country like Morocco. For instance, we want to know what's underground on Mars. Okay, and instruments like geophones and ground penetrating radar and electromagnetic sounding equipment, which of course are a great interest for geology and the oil industry and things like this, to apply that expertise to developing instruments for underground exploration on Mars and drilling kinds of things. Here's the thing. On Mars, okay, you're not going to want to go to Mars with, 1,000 meters of pipe to drill and put one after the other, and as it goes down, because that is too much mass. But imagine, I don't know if you have moles in Morocco, but these are little animals about the size of mice, and they can dig through the earth. They don't make a tunnel. They just take the earth in front of them and put them behind them. And then they take the earth in front of them and put it behind them. And they can keep moving through the earth this way. There's no tunnel. There's just them moving the dirt in front of them, behind them. They're almost like swimming through the earth, if you think. And creating underground probes that use that principle, where you don't have to have a whole bunch of pipe to keep a tunnel open, but just a wire to keep powering it. There could be a lot of use for that in geological explorations, for minerals, for oil, for all sorts of things, and water. So, this is something that perhaps people could get interested in, because a simple, lightweight mechanical mole powered by a wire that can move through the earth and find things, find water, find oil, that's a very useful thing.
This is the wise decision. I think investing in this is an industry, increasing industry, and I think it's a wise decision to invest in the space industry. Honestly, as Moroccan engineers, we are I know a group of people that are thinking about doing a study to prove that it's a possibility to do a spaceport in the Moroccan deserts, based on the location of Morocco, and that's already. I'm not waiting for our government to do action. Honestly, personally, and a friend of mine, we are trying to create this company that we can send CubeSats to the low orbit, and from student universities help them send CubeSats and try to explain to these to Moroccan students that everything is possible, and just to make them start interested by the space industry. That's the first step, not Mars. Sorry. Yeah, thank you, Mr. Robert. I think there are a lot of questions, Osama, that you can from the public that are very interesting. You can show them to Mr. Robert.
Okay. So, Robert, if we succeed exploring Mars, what would be our next destination?
Okay, well, we will explore Mars and we'll settle Mars. There'll be new cities, new nations on Mars. But after that, yes, the asteroids that are thousands of small planets that orbit between Mars and Jupiter are places that we can go to. And then even the moons of the outer planets. But I also think, you see, if we settle Mars, you create new cultures there. They're going to make new inventions. I'll give you an important example. Okay. They're obviously going to need energy. Now, on Earth, there's lots of ways you can get energy. You can get oil and gas and coal. You have waterfalls. You have wind power. You have solar power. You have nuclear power. Okay, all these things are possible. Now, in fact, the dominant form of energy use on Earth is fossil fuels, except where you have water power. Well, that's a free lunch. Okay, fine. But but on Mars there are no fossil fuels, and there won't be any water power on Mars until we terraform it. And the solar power is only 40% as strong as it is on Earth, and on Earth it's really not that attractive. We'd be using a lot more of it. The air is too thin to get much wind power. And yeah, you could make nuclear power, but you need a big industrial base to do nuclear power, separating uranium from the ores. It was at most 1% uranium and so forth, and enriching it and all this. But you know what there is on Mars? Mars has deuterium, that is heavy hydrogen, is 6 times more common on Mars than it is on Earth. And that's the fuel for fusion reactors. Now, nobody's been in a big hurry to develop fusion reactors on Earth because we have all these other kinds of power. They say, oh,
Yes.
yeah, you might be able to do fusion, but is it going to really be cheaper than natural gas? Well, I don't know. Well, when you know that it's going to be cheaper than natural gas, then come to me and we'll talk about fusion. But on Mars, there is no natural gas. So I think the Martians, by which I mean the people that go to Mars and live there, they're going to have a very strong incentive to want to develop fusion power because they've got the fuel and they don't have alternatives. So the Martians will develop fusion power. And guess what? When they develop fusion power, then fusion power will become available to Earth too. But furthermore, fusion power enables new kinds of rockets, rockets that can get up to 10% the speed of light. And so what you'll have there is a technology that at least gives you a beginning capability for interstellar travel. So Mars is going to open up new possibilities, great new possibilities.
Okay. So, Mr. Robert, are you ready to take a travel and go to space on a mission to discover Mars?
Would I go to Mars if I had a chance? Is that what you're
Yeah.
asking? Yeah, I would. I would. I don't think I'm going to. I'm a bit old for it now. And frankly, it's been one of the great disappointments of my life because I was 17 when we landed on the moon. And if anybody told me that I'd be 69 and we wouldn't have cities on the moon and Mars, I would have thought they were crazy then.
Yes.
But we had a major failure of political leadership in the United States following the Apollo program. It's almost like, imagine if Columbus had come back from the New World the first time and said, look, I just discovered a new continents, and Ferdinand and Isabella said, oh, we don't care, go away. Get lost. That's kind of what happened. But now we're coming back, and I think the thing that's really new this time is that a lot of the leadership is coming from below, that is not coming from presidents, it's coming from businessmen, like Elon Musk. And so there's a lot more different sources of initiative here. And if one doesn't do it, another one will. And what Musk has demonstrated is possible for a well-led entrepreneurial team to do things that previously was thought that only the governments of superpowers could do. And not only that, do it in 1/3 the time, at 1/10 the cost, and even do things that they had decided were impossible. So, and others are getting into the game. There are Chinese companies that want to be a rival to SpaceX. There are others forming around the world, and this is just going to happen now.
Yes, and I think that you want to be with Elon Musk and Mars.
Mm-hmm.
So there is a good question from Facebook comments. Is there a way to do small-scale Mars warming test just to make sure things work as planned before going full-scale on a planet?
Well, to some extent, you can test the optical qualities of these artificial greenhouse gases. Like my favorite one is called perfluoromethane, or carbon tetrafluoride. The chemical formula is CF4. You could use it to test its ability to function as greenhouse gas. You could use it to test its ability to resist dissociation by ultraviolet light, so that it will actually last once you put it in the atmosphere. You can also make sure that it doesn't destroy ozone, which so far indications are that it does not, because you want ozone. Mars does have an ozone layer like the Earth, and this is important protection to the surface. So we can do some experiments, but to test planetary warming, you gotta have to do it for real. The people who are going to do this, it's not us, the Earthlings. It's going to be done by the Martians, okay? Because they've lived there. and this is going to be a big operation. It's going to be expensive. So to who is it worthwhile to do something like this? The people that live there, you know. It's not people in America running around thinking of ways to do irrigation projects in Morocco. It's Moroccans, okay, and so it's the Martians are going to decide how they're going to change their planet.
Okay. There is another question from Paulo. By the way, is a Brazilian researcher. So Paulo asked, Mr. Robert, why not send a basic technological that with some life support to give 2 to 3 months for some people that no care died on Mars after they no money research is possible too.
There are people who talk about one-way missions to Mars. And look, in a way, life is a one-way mission. We're all going one way to somewhere. But I don't think if we do one-way missions to Mars, we don't go and say, well, you can go there and live for 3 months and then you're going to die. No, you go and you say, we're going to send enough supplies with you for several years. And before those years are up, we're sending more supplies and more people and more equipment. And we're going to just build this thing up bigger and better. In other words, it's not go one way and then die. It's go one way and then settle. That's how we should do it.
Okay. So thank you so much, Mr. Robert, for speaking to our community about Mars. The community who attend really enjoyed our conversation. We appreciate you making time in your busy schedule to speak to our Moroccan community. So thank you again for your time.
Okay, and I hope you form a Mars Society in Morocco. And, we're going to have another convention this year. I think it's going to be a teleconvention like it was last year. So people from all over the world can attend easily and for free. You don't have to travel. You don't have to go into a hotel. But you can still present papers and listen to talks as well.
Yes. You're welcome, Mr. Robert, and thank you again.
Okay, well, thank you. And if you post this on the internet, please send me a link and we'll repost it as well.
Okay, I will send you the link in the email or LinkedIn.
Either way.
Okay, thank you so much, Mr. Robert.
Thank you. Okay, bye.